Continuing our exploration of multiple choice final practice problems from section 8 at Moodle. We have which of the following would give a good yield in the reaction below. Shade all letters that apply. Butane becoming Z2-butene. So we have this one becoming this one. I know H2 and Lindlar's catalyst does this. Oh, that's one of the choices. But there's another choice that gives the same result. It's called hydroboration / protonolysis. Not hydroboration oxidation, which is also listed. That would give a ketone in this case. Why a ketone and not an aldehyde? Students are saying, wait, he said hydroboration followed by oxidation. I memorized in chapter 7, when you do that, you get an aldehyde every time. Why do you not get an aldehyde with step D this time? It's an internal alkyne. You can't make an aldehyde with an O on the end. You got a ketone. Okay? D gives that. Okay? E gives this. So does B. Those are your answers. B, E. Hydroboration / protonolysis goes like this in E. Just a quick summary. E. Syn addition of B and H. And then protonolysis. Protonolysis gives the final result. Okay? And that's what happens. Okay? Yep, there's a few of these little itty bitty nomenclatures on here. So why does this have to be carbon number 1? Yeah, double bond as low as possible. So what are they trying to do with that vinyl thing there? Who are they trying to trick? Those 2 vinyl answers are wrong. Because if you choose that to be a vinyl group up here, then you don't get the 6 carbons for your chain, do you? That's the answer. So we're down to 2 choices. Basically, it's S versus R now, isn't it? No, it's not. Yeah, honestly, it's only one choice, he says. I believe her. It's the hexene choice. Yeah, what's propyl? Oh my goodness, they counted this as a group, and they went 1, 2, 3, 4. That's goofy. Man, we didn't even have to verify the stereo center. Oh man, can we verify the stereo center though? We got a 4, and a double switch time, right? And a 2, and a 3, and a double. 4 is now switched with 2, switch with 3 is now switched with 1, and it's R. Buffer. Buffer is prepared by mixing 1 mole of carbonic acid. Oh no, I thought he was going to give us the pKa's for all the buffer problems. What's carbonic acid's formula? What's pKa? You need to know it. Should be similar to a carboxylic acid, shouldn't it? No, it's not quite as good as a carboxylic acid. No, not quite as good. You give me 1 unit away, not 10. I noticed that. I did notice that. pKa's make things work. There's carbonic acid with a terribly drawn O. Doesn't it look a little like a carboxylic acid? Please pick a number similar to a carboxylic acid number. Okay? So it's 6. And I want to point out, when it loses an H, it's still an acid. Okay? This is the conjugate base, right? But it could be an acid if it needs to be. also an acid. pKa equals what? You can't go below 6. I mean, it's the second proton, and they don't go down in number. They go up. They're harder to take off, the second one than the first one. So what's the number? You say 11? Nice answer. There you go. Yeah, if we didn't know the 2 pKs of carbonic acid were, we can't start this problem. It's that simple. First pKa is for carbonic acid itself, and the second step is the second acid is 11. We just got to figure out which of those is the acid when we're done in this question. One or the other. So we got H2CO3, 1 mole. I'm not doing ice problems if I don't have to. Goes to HCO3 minus 1 mole. That's gone. And then how much hydroxide did you use to do such a thing? 1 mole. Any hydroxide left? 0.6 moles. Minus 0.6 for that, leaves 0.4. And what do you make? What's the next step? Make? What does hydroxide do? Take away protons or add protons? Take away protons. Give me what's left after you take away a proton from HCO3 negative. Yeah, what's the name of CO3 2 negative? Carbonate. And you started with 0 and you made 0.6. There's your ice. Well, that's not a highlighter. You have 0.6 of the base, and you have 0.4 of the acid. How do you know that's the acid? Comparing the two structures, HCO3 minus and CO3 2 minus. Which one's the acid, period? The one with the H. So yeah, which pKa is now in play? Don't tell me 6. I crossed it off a long time ago. 11 is in play. Am I above 11 or below 11? I have more base than acid. Does base raise or lower pH? Raise. Raise. Yes. You're so Arabic. She says, higher the pKa, Dr. Whitaker. She's right. No, it's very accurate use of language. I do like that about the language. Okay. So, yeah. I need an answer a little above 11. AE, yeah. AE. And I go like this. I put an up arrow because there's more base than acid, right? It's a multiple choice, so you don't have to show any work if you don't want. And AE 11.1 is the only answer that's a little above 11. Good question.